So today I'm going to review the real number system. First of all, anytime you hear the word real number, that includes all numbers. Actually, you probably want to pause the video for a second and go ahead and set up this chart in your notebook and pause as needed to fill in the graphic as we go. But for real at the top, that's why it's at the top, that is all numbers. So when I say all numbers, I mean positives, negatives, fractions, decimals, square roots, perfect square roots, non-perfect square roots. Any number that you can think of, it is real. So then you get to classify into two major categories. We have rational and irrational. So I'm going to talk about irrational first, just because it's the most elite. You have the fewer numbers that are irrational. So let me give you some examples of irrational numbers. First of all, it's any non-terminating, non-repeating decimal. So we've got an example like 15.97354 ... Now, what does that ... mean? It means that we're going to keep going forever. We have no idea what the next number is. It's going to be some crazy, not a pattern. We don't know what to expect. That's why we call it irrational. Also, something that you're familiar with, pi. Anytime you see pi, you know that it's irrational, because you know from the past that pi never ends and it doesn't have a pattern. So you could see just the plain pi. You could see 13 pi. You could see 4 pi over 12. Anytime you see a pi anywhere, pi plus 3, all those are irrationals. And then finally, anytime you take square roots of non-perfect squares. So we've been looking at perfect squares. Perfect squares are like 49 or 25. But what about 40? 40 is not a perfect square. So if you were to take the square root of that, it's going to be some long, crazy decimal. So we make it irrational. Another one would be like 112. It's another non-perfect square. So 112, square root of 112 is irrational. So those are your special irrationals. If I think of any other ones as we're going, we'll come back to those. But those are your irrationals so far. So then that means everything else is rational. So the first thing we're going to do, like fractions. Fractions are your most common. Anytime you can write a number as a fraction, it's rational. Fractions or decimals that are not like this. So a fraction like 5/8, or a decimal like 2.9, or let's see here, 8.3. Repeating decimals are okay. They're rational. Remember, only these crazy ... dots are irrational. So then we have some categories under rational that we can subdivide. So the next one is called integers. So integers are all your positive and negative whole numbers. So anything positive or negative, no fraction, no decimal. For instance, -12, -6, 0 is included in it. 52, 739, all of those are integers, positive or negative whole numbers, and include 0. So within integers is another category. Those are called whole numbers. The only difference with whole numbers is they have to be positive. None of the negatives. So like 1, 2, 12, 74. All those are whole numbers. Oh, and don't forget, 0 is still included in that as well. And then finally, under that, we have natural numbers. And natural numbers are the ones you're most used to. That's your counting numbers. Counting numbers. So the only thing that's different between natural numbers and whole numbers is the 0. So 1, 2, 9, 24, 783,294. All those are natural numbers. So given something like this, you may have a, let's see, square root of 144. So it's a square root. Is that a perfect square? Would it be rational or irrational? So the square root of 144 is 12. So we can say about 12. First of all, we start at the top. It's real. Then, is it rational or irrational? Well, it's not some crazy decimal, and it's not an imperfect radical, and it's not got pi in it, so it is rational. Then we have, is it an integer? Is it a positive or negative whole number? Yes. So it is an integer. Is it a whole number? Yes. And then is it a natural number? Yes, it's one of your counting numbers. We'll do one more. How about the square root of, let's see, 49 over 400? That's okay because they're both perfect squares. So the square root of 49 is 7, and the square root of 400 is 20. So now let's start at the top. It's real. All numbers are real. Now, is it a rational or irrational? Well, it's written as a fraction. Fractions are rational, so it's rational. The next question, is it an integer? Is it a positive or negative whole number? Well, it's a fraction, so that knocks it out. So once we stop, it is not a whole number, so now we're done. It can't be a whole, if it's not an integer, it can't be a whole number, and it can't be a natural number. So these are the classifications. The biggest thing that you need to focus on is, are they rational or irrational? And sometimes it gets into these. But pay close attention to that pi. Pay close attention to these square roots of non-perfect squares and these crazy decimals. Those are your irrational. Everything else is rational.